Good evening everyone. Tonight, I will be presenting our research on aromatic hydrocarbons. This presentation will cover two categories: benzenoids, which consist of one or more benzene rings, and non-benzenoids, which do not contain any benzene rings. I will provide information on the properties and applications of both categories to demonstrate the potential of these compounds. So, let's get started. Aromatic hydrocarbons are a class of organic compounds that contain one or more benzene rings, which are composed of alternating double and single bonds between carbon atoms. They are known for their strong odors and have various industrial, agricultural and medical uses. Unfortunately, they are considered a major source of pollutants in the environment. Aromatic hydrocarbons are a special type of chemical compounds that are characterized by their strong, pleasant odor. This odor is due to the specific arrangement of carbon and hydrogen atoms, from which they also derive their name. They are also known as aromas, in reference to their aromatic smell. Organic compounds known as aromatic hydrocarbons consist of carbon and hydrogen atoms organized in a ring format. Examples of these hydrocarbons are benzene, anthracene, furan, thiophene, and the more intricate naphthalene. These compounds have unique chemical properties and often demonstrate certain similarities to benzene. Kekulé's pioneering work in 1865 provided a starting point for further investigation and discussion about the structure of aromatic hydrocarbons. Subsequent measurements of atomic weights, molecular weights and refractive indices suggested the presence of a benzene ring composed of 6 carbon atoms linked via alternating single and double bonds. This discovery of the structure of the benzene ring was a significant step in gaining knowledge of the stability of aromatic compounds. Benzene is a remarkable hydrocarbon due to its distinct 6-membered ring structure, which consists of sp2 hybridized carbons with 3 double bonds spread around the ring, resulting in its striking stability and reactivity compared to other common hydrocarbons. Regarding aromatic hydrocarbons, it is necessary to satisfy certain criteria for a compound to be classified as aromatic. Such criteria include cyclicity, planarity of all atoms, all electrons being fully conjugated, and Huckel's rule, which indicates that compounds must possess 4n+2 pi electrons. Therefore, it is crucial to keep these criteria in mind when studying aromatic hydrocarbons. Hydrocarbons are organic compounds made up of hydrogen and carbon atoms. When hydrocarbons are cyclic, planar and have 4n+2 pi electrons, where n equals 1, they become aromatic. This means they form a stable ring structure and an electron cloud that can be distributed across the molecule. Some examples of aromatic hydrocarbons are benzene, pyrrole and 1,3-butadiene. However, 1,3-butadiene, non-aromatic cyclic planar molecules with 4n+2 pi electrons, do not contain this type of hydrocarbons. Nitrogen and hydrogen can also form aromatic hydrocarbons. According to Huckel's rule, cyclic conjugated molecules with an even number of electrons, such as 4n+2 electrons, are aromatic. Therefore, the correct answer to this question is C, 4n+2 electrons. Aromatic hydrocarbons are organic compounds containing at least one benzene ring, a six-membered ring of carbon atoms with alternating single and double bonds. They are highly stable, exist in liquid or gas form, are highly flammable and have an aromatic smell. Aromatic hydrocarbons find uses in many industrial processes, including as solvents, dyes or components of gasoline. Aromatic hydrocarbons are organic compounds containing one or more benzene rings. Examples of these hydrocarbons are benzene and benzaldehyde. These hydrocarbons can further be divided into 5 distinct classes based on their chemical structure. Aromatic hydrocarbons are a large class of organic compounds that can be divided into 2 main classes: benzenoids and non-benzenoids. Non-benzenoid aromatic hydrocarbons, like furan, thiophene and pyridine, have different properties from benzenoid compounds. These compounds contain one or more heteroatoms, such as oxygen, sulfur or nitrogen, in their structure, giving them particular characteristics that make them useful in many areas. Comparing aromatic and aliphatic compounds, aromatic compounds contain higher percentages of carbon and generally prefer substitution reactions. Aliphatic compounds, on the other hand, contain lower percentages of carbon, burn with a non-sooty flame, and usually undergo addition reactions. To demonstrate this, let's consider the example of benzene and hexane. Benzene has an overall percentage of carbon of 92.30%, while hexane has an overall percentage of carbon of 83.72%. This illustrates the differences between aromatic and aliphatic compounds. Aromatic hydrocarbons are a class of organic compounds that contain carbon and hydrogen with one or more alternating single and double bonds of the benzene ring structure. Naphthalene belongs to the group of benzenoid compounds, which have the aromatic benzene ring structure. The 3 categories of aromatic compounds are benzenoid, non-benzenoid, and anti-aromatic compounds, and the correct answer is A. Benzenoid. Benzene is an aromatic hydrocarbon with 6 pi electrons. It is a key component in the production of polymers and a foundation chemical for styrene and phenol. Additionally, it is used in the manufacture of plastics, solvents, lubricants, and detergents. Aromatic hydrocarbons, referred to as arenes, are a range of organic molecules featuring a ring-like structure. This configuration accounts for the specific physical and chemical traits of arenes, which makes them widely used in a range of industries and purposes. Part 1 of this presentation will examine nomenclature of aromatic compounds, covering their naming and categorization. Aromatic hydrocarbons in which only one hydrogen atom is replaced by an alkyl or functional group are referred to as monosubstituted benzene. Examples of such compounds include chlorobenzene, nitrobenzene and bromobenzene. Naming these compounds is done by attaching the name of the substituent to the word benzene as a prefix. This is a straightforward system for identifying these specific aromatic hydrocarbons. Hydrocarbons with an aroma contain compounds like phenol, toluene, aniline and benzoic acid. These compounds are referred to by their common names that have been accepted by IUPAC and generally follow a given nomenclature. To illustrate, phenol holds an OH group, toluene an NH2 group, aniline an NH2 group, and benzoic acid a COOH group. Aromatic hydrocarbons can be difficult to comprehend. A rule for determining their structure is that if the alkyl group is larger than a benzene, then the benzene will become the substituent and will be referred to as phenyl. For alkyl groups with more than 6 carbons linked to a functional group, it will become benzyl. This can help one distinguish between various aromatic hydrocarbons and correctly identify them. Aromatic hydrocarbons and their compounds will be the focus of this discussion. These compounds are carbon-containing structures that have a ring of carbon atoms with one or more substituents. The parent carbon chain of these compounds may contain single, double, or triple bonds at certain points. Heptane and butane are examples. Substituents are further determined by their structure, 1-nitro and 2-phenyl being 2 of them. The special properties of these substances are a result of their distinct structure. Examining 4 different aromatic hydrocarbons, starting with 1-nitro-3-benzene carbaldehyde, 3-nitrobenzene carbaldehyde, 3-formyl-nitrobenzene, and all the above. The IUPAC name for the compound given as 2-nitro-3-formylbenzene. Aromatic compounds have specific characteristics, and this slide looks at the different hydrocarbons. Carbon-based compounds known as aromatic compounds have unsaturated ring structures. This slide covers the nomenclature of aromatic compounds, including the rules for naming the various types and some common examples. By the end of this slide you should be familiar with the process of naming these molecules. Aromatic hydrocarbons are a group of compounds known for their strong connection networks. These molecules are made distinct by the presence of an aromatic ring system. The strong stability of the molecules is attributed to the structure of the aromatic ring. Disubstituted benzene is one type of aromatic hydrocarbon, wherein two hydrogens of the benzene ring are replaced with functional groups. Depending on the positioning of the substituent, the isomer is characterized as a meta, para, or ortho. Each isomer giving different properties. Thus, aromatic hydrocarbons provide many potential applications for research and development. Organic compounds are classified by prefixes. For instance, aromatic hydrocarbons with two substituents attached to a benzene ring are indicated by the prefix D. A good example is 1,2-dichlorobenzene, when two chlorine atoms are attached. Similarly, when two nitro groups are attached, the compound is referred to as 1,3-dinitrobenzene. This is a fundamental principle for classifying organic compounds. Aromatic hydrocarbons are organic compounds made up of carbon and hydrogen, and for different substituents they can be numbered and entered in alphabetical order. It is important to note that there is a correct and incorrect way of numbering. For example, for iodobenzene the correct form would be p-bromoiodobenzene, and for nitrobenzene it would be m-chloronitrobenzene. Accuracy is paramount, as incorrect numbering could lead to miscalculations. Hydrocarbons, which are aromatic, are a kind of organic compounds that have a carbon-hydrogen bond and an aromatic ring or a cyclic hydrocarbon. 2-chloroaniline is one such compound, and it falls under Rule 3 of the IUPAC system of nomenclature. This rule states that if one of the two groups has an exclusive name, the molecule is named as a derivative of that exclusive name. So 2-chloroaniline is just a derivative of aniline where a chlorine substituent has been added. This slide contains several examples of aromatic hydrocarbons, specifically molecules CH3NO2, M-nitrotoluene, 3-nitrotoluene, O-bridge, p-bromophenol and 4-bromophenol. These molecules appear in many everyday products. When two or more of these hydrocarbons are connected, they are referred to as derivatives. The naming of the molecule reflects this, as seen in the given examples. When it comes to naming a compound containing a special group, there are certain rules to follow. For example, when referring to a compound with an ethyl group, a methyl group, an aniline group and a hydrogen group, the lowest possible combination is 1 + 5 + 6, or 12, and the highest possible combination is 2 + 3 + 4 + 1 + 2 + 3 + 4 + 5 + 6, or 45. Similarly, with a compound containing a chloro group, a nitro group, and a phenol group, the lowest possible combination is 1 + 4 + 6, or 11, and the highest possible combination is 2 + 3 + 5 + 6 + 4 + 1 + 1 + 2 + 3 + 4 + 5 + 6, or 56. These rules must be applied in order to name the compound correctly. Discussing aromatic hydrocarbons, Rule 5 states that when more than two groups are attached to the molecule, they should be numbered in such a way that the combination of numbers is the lowest possible. For instance, 1,2,4-tribromobenzene gives a combination of 7, whereas the highest combination it could have is 11. Similarly, 4-bromo-1,2-dimethylbenzene gives a combination of 7 as well, while the highest combination it could have is 11. This rule is essential for properly labeling aromatic hydrocarbons. This structure of M-dinitrobenzene is composed of two benzene rings double bonded with one nitrogen atom between them, and each ring has two nitro groups attached to it. This is a type of aromatic hydrocarbon, a class of compounds with resonance-stabilized rings of carbon atoms connected with strong covalent bonds. When it comes to aromatic hydrocarbons, their names can be quite confusing. Acetophenone, benzaldehyde and benzoic acid are compounds that all contain the COOH chemical formula. They are also the main components of C documents and settings user desktop images JPG. Thank you for your attention.